Welcome to our channel. Today we're journeying into the heart of the solar system, to where Mercury hides ice in hell, Venus boils in sulfuric acid, and Mars whispers of ancient rivers. We'll look beneath the ice of Europa, walk through Saturn's hexagonal storm, and find a nitrogen heart on Pluto. Giant collisions, vanished oceans, biosignatures of life, and a ghost planet on the edge. All this awaits us. Close your eyes, turn on your imagination, and let's fly. Mercury, close to the sun, hot, but with surprises. Mercury is the tiny planet, the closest to the sun, where it's hotter than an oven by day and freezing at night. It seems like a simple rocky desert, but it's not. Ice hides there in the shadows. Craters look like spiders, and volcanoes might still be smoking. It's a world that defies expectations. Let's break down its secrets step by step. High density. What makes the planet heavy? Hypotheses about the core and past Mercury is the smallest planet, about the size of a football field, but it weighs as if it were packed with lead. If you took a sugar cube sized piece of Mercury, it would be heavier than the same size piece from Earth. For comparison, Earth is heavy, but Mercury breaks all records among small planets. It's 1.5 times denser than Mars or the Moon. Why such heaviness in such a tiny body? It's all about its insides. Mercury has a huge core. It takes up almost 80% of the planet, like a large stone in a small fruit. This core is made of pure iron and nickel, the heaviest metals. Outside is a thin shell of light rocks, only about 300 kilometers thick. Imagine an apple where the core is a steel ball and the skin is paper thin. The MESSENGER probe, which orbited Mercury from 2011 to 2015, measured this. The core is so large that the planet seems like a lead dumbbell. But where did such a core come from? Scientists think Mercury was not born this way. 4.5 billion years ago, when the solar system was a young and volatile place, planets collided like cars in traffic. Mercury could have lost its light shell in the distant past, perhaps from a harsh impact that stripped away the outer layers, leaving only the heavy interior. Or it formed closest to the sun, where the young sun's magnetic field attracted iron, like a magnet attracts crumbs. Another option: the sun's heat simply vaporized the light rocks, leaving the metal behind. In 2025, the Bepi-Colombo probe confirmed Mercury's rock has few light substances, as if someone stole them. This density is not just a fact, it explains a lot. Because of the large core, Mercury has a weak magnetic field, like a mini shield against solar wind. Plus, such heaviness makes the planet stable, despite its proximity to the sun. But the mystery is why the core hasn't cooled over billions of years. It's still partially liquid, like molten metal in a forge. This keeps Mercury alive. Scientists debate maybe there's sulfur inside, which prevents the core from solidifying, like salt in water. Or the sun massages the planet with tides, heating the interior. Without a dense core, Mercury would be a dead rock, but this way, it's full of surprises. Ice at the poles, where water comes from in the inferno, sources and traps. Mercury is a hellish frying pan, where it's plus 430 degrees Celsius by day, lead melts, and minus 180 at night. But at the poles, in dark craters, ice hides real water ice. How much? Billions of tons, like a small iceberg. How does water survive in such an inferno? It's like finding a refrigerator in a sauna. The ice sits in eternal shadows, deep pits at the poles that the sun never shines into. The temperature there drops to minus 170 degrees Celsius, colder than on Pluto. MESSENGER in 2014 shone a laser and saw the crater floor shimmer like frost. The ice has been there for billions of years. It doesn't melt or escape because the vacuum and darkness keep it trapped. Where did the water come from? The first option is comets, those cosmic snowballs. They flew into Mercury and broke up, scattering ice. Some vapor settled in the cold pits like dew in a cup. Over billions of years, a lot accumulated. Second asteroids with water inside the rocks. Upon impact, water is released and flies into the shadow. Third, the planet itself. Solar wind hits the rocks, knocking out hydrogen and oxygen, which combine into water and freeze. Bepi-Colombo in 2025 found organic matter on top of the ice-black dust, like a blanket, that prevents the vapor from escaping. Why doesn't the ice evaporate? In space, water escapes quickly, but not here. The shadows are eternal, and the dust seals the ice like a lid. In some craters, the ice is mixed with dirt, meaning it accumulated gradually. This is not just water, it could be fuel for future missions. The mystery is why the ice is different. In some craters pure, in others with impurities. Did comets bring different snow? Or does the planet make water itself? Ice on Mercury is proof that even in hell there is coolness, and water is everywhere, even right under the sun's nose. Spider-like craters and hills, strange landforms, causes. Mercury's surface is like an old map with a bunch of craters, but among them stick out spiders and hills that look like alien design. Spiders are huge craters from which cracks spread in all directions, like legs. The coolest is in the Apollodorus crater, 200 kilometers in diameter, with legs up to 100 kilometers long. And the hills mounds up to a kilometer high, grouped like an anthill. Why such shapes when there are only regular pits everywhere else? Spiders are not simple craters. Messenger showed there are about 10 of them, and all in volcanic zones. One idea is volcanoes. Magma rose, pushed the crust, and then left, and the ground cracked into a web, like dough that puffed up and burst. Another is planetary contraction. Mercury cooled, shrunk like a shriveled apple, and cracked in the weak spots of the craters. A meteorite impact weakened the crust, and bang, a spider is ready. In 2023, models showed if the impact and contraction happen together, cracks tear radially like a spider web. The hills are simpler. They are in lava plains like frozen bubbles. Option 1, volcanoes. Lava swelled into domes, froze into mounds. There are such on Earth in Hawaii. Second contraction, the crust was squeezed up like folds in a blanket. Third wind and micrometeorites wore away the soft, leaving the hard hills. Beppe Colombo in 2025 found the hills are richer in minerals than the plains, meaning volcanoes. But why are they fresh? There are few craters on them, as if they grew yesterday. These forms are traces of a tumultuous past. Mercury's thin crust, only a few kilometers, breaks easily, and proximity to the sun adds heat. Spiders and hills show the planet contracted, volcanoes boiled, impacts struck. Without an atmosphere, there is no erosion. Everything is preserved like a museum. The mystery, why are there few spiders? Maybe new ones are hiding. These features are like scars, telling how Mercury survived the heat and chaos. Volcanism, recent eruptions, signs and traces. Mercury seems like an extinct volcano, but lava traces cover half the surface, huge plains like frozen rivers. It was long thought volcanoes died out 3 billion years ago, but data suggests lava flowed later, maybe 100 million years ago. That's yesterday for a planet. Were there recent eruptions? Messenger found young plains with few craters, meaning fresh. Around the Calorus Basin, the lava is less than 1 billion years old. Even cooler are facialae, pits with bright halos like exploded soda. This is gas from magma breaking through, ejecting dust. There are hundreds of facialae, and some are only tens of millions of years old. In 2024, it was calculated the age of faculae is from 100 million to 1 billion years. Recently, why didn't the volcanoes die out? Mercury's core is liquid, heat is retained. Plus, the elongated orbit, the sun alternately pulls and releases, heating the interior with tides like a microwave. Crustal contraction tears, cracks, magma climbs up. Lava on Mercury is liquid, like syrup, pour in gases, it flowed far. But the faculae are explosive, with gases inside. Beppe Colombo is looking for fresh traces. In 2025, it found gases in the atmosphere, perhaps from volcanoes. The mystery, are they currently active? No fresh flows, but the faculae are young. Maybe the volcanoes are dormant, waking up rarely. Or do meteorite impacts simulate faculae? For colonists, this is important. Lava is a risk, but also energy. Mercury's volcanoes are like coals in a fire, smoldering, waiting for a spark. The planet is not dead. It breathes under the crust. Venus, Earth's twin, but a hellish world with atmospheric secrets. Venus is almost a copy of Earth in size, but inside is a real hell. Heat melts metal. Pressure crushes like under a kilometer of water. Clouds hide everything. Winds carry secrets, and beneath them, ancient lands and strange snow. It's a planet that was similar to ours, but went a different way. Let's dive into its atmospheric secrets. Retrograde rotation. Why not like others? Impact hypotheses. Venus spins differently than all other planets, clockwise, slowly, like a sleepy turtle. One rotation is 243 Earth days, longer than a year. Earth rotates in a day, Mars in a day. If viewed from above, Venus goes backward. Why is it so disobedient? When the solar system was born, all planets rotated in one direction, counterclockwise, following the gas disk around the sun. Venus also started that way, but something flipped it over. The main idea is a large impact in the distant past. 4 billion years ago, in the chaos of collisions, a body the size of Mars slammed into Venus. The impact was oblique, like a push in billiards. It slowed the rotation and flipped it backward. Computer images from 2020 show. Such a push changes the direction in one go. The impactor could have brought its own angular momentum, like a figure skater changing speed. There are other ideas. Venus's atmosphere 90 times denser than Earth's could have braked the planet with friction, like a wet brake. The sun pulls with tides, turning Venus backward, or Jupiter nudged it with gravity. But these ideas are weaker. They slow it down, but don't flip it. In 2023, models showed without an impact, Venus would rotate normally. The impact also explains the lack of a magnetic field. Because of the slow rotation, the liquid core doesn't move actively enough to generate a field. Why is this important? Because of this rotation, the day is hotter than the night. The climate is insane. The sun rises in the west. Future probes, like Da Vinci in 2030, will look for impact scars in the crust. Venus is a reminder. One push changes everything. Greenhouse effect. How it became hot, role of gases. Venus is the hottest world in the system, plus 460 degrees Celsius, lead flows like a river. Close to the sun, but Earth is cooler. Why? The atmosphere is like a thick blanket of carbon dioxide that holds in the heat. Venus's atmosphere is 96% carbon dioxide, with pressure like under an ocean. Solar rays pass through the clouds, heat the ground, but the heat doesn't escape back. The gases trap it like a mirror. The same happens on Earth, but weaker. Oceans and forests consume carbon dioxide. Venus lost its water, it evaporated from the heat, and the gas remained suspended. How did it start? Billions of years ago, Venus had oceans, like Earth. But closer to the sun, more heat. Water evaporated, becoming steam, a super greenhouse gas. The temperature rose, the oceans went into the sky, the gases amplified the heat, volcanoes added carbon dioxide like factories. In 2020, models showed over hundreds of millions of years, Venus boiled itself. Sulfuric acid clouds reflect light but hold heat inside. There is no magnetic field, the solar wind carried away the water. The pressure, 92 times that of Earth, compresses the air, adding heat. Akatsuki in 2015 saw volcanoes still smoking, feeding the gases. This is a warning. Earth can also heat up this way from our gases. Venus is an example of a planet losing balance. The mystery, was it once green? Traces of water in the rocks say yes. Snow on the mountains, composition, how it precipitates. The heat on Venus is hellish, but on the mountain peaks, snow. Shiny like frost on peaks higher than 2 kilometers, not water that evaporated. Magellan, in the 1990s, shown a radar, the Maxwell-Montes glow. What is this snow made of and why only at the top? It's metallic flakes, pyrite, iron with sulfur like gold dust, and tellurides, bismuth, lead. Resistant to heat, volcanoes puff out sulfur, gases rise. It's colder at altitude minus 30 degrees Celsius below than at the bottom. Gases cool, crystals settle like snow in winter. Above 2 kilometers, it's ideal. Below is hot, gases don't condense. Venus Express in 2008 found sulfur in the air fuel for the snow. Pyrite shines on radar, tellurides add sparkle. In the lowlands, the snow melts into gas. On the mountains, it lies in a layer of centimeters. Another thought, chlorides or pure sulfur, but pyrite winds rock analysis fits. Why only mountains? Like snow on Earth's peaks. The atmosphere is turbulent, but altitude is a barrier. In 2021, models showed the temperature difference is the key. The snow is fresh, volcanoes are active. It's beautiful, hell with white caps. For probes, a landmark. The mystery, how many layers? Maybe ancient rocks are under the snow. Clouds. What's in sulfuric acid, phosphine, and life? Venus's clouds are a yellow blanket at an altitude of 50 kilometers made of sulfuric acid like poison. Dense, rotating in a vortex. But in 2020, phosphine was found a gas from bacteria on Earth. Life in hell? The clouds are acid drops, the temperature is 0 degrees Celsius, the pressure is like on Earth. Ideal for microbes? Phosphine 20 parts per billion. On Earth, it's made by bacteria in swamps. In Venus's atmosphere, it's destroyed by ultraviolet, a source is needed. ALMA and SOFIA telescopes confirmed it's there. Hypotheses: microbes float in drops, eat acid, exhale phosphine. Earth bacteria live in acid, the analogy works. In 2024 models, ammonia neutralizes the poison, making a cozy home. Dark spots in ultraviolet organic matter from life? But it's not simple. Volcanoes could have provided phosphorus, reactions in the air phosphine. Meteorites bring it. In 2023, it was calculated. Too few volcanoes for such a quantity. Rocket Lab will fly in 2025, it will check the gases. Ultraviolet shows stripes unknown chemicals. Organic matter? Life? The clouds are the only place on Venus for it. The mystery. If microbes, why isn't phosphine everywhere? Da Vinci will dive in 2030, it will give samples. Venus teases. Life above hell? Tesserae. Ancient continents. Formation under Venus's clouds is a mosaic of ridges and cracks like cracked tile. These are tesserae old continents, 8% of the surface, high, fractured, with lots of craters. The analog of the Himalayas, but ancient tesserae are in Alpha Entellus Regio, raised by a kilometer. Magellan showed crisscrossing cracks, ridges. The crust crumpled like fabric. The age is billions of years, not flooded by lava. Venus Express found granite-light rocks like on Earth. How were they born? The mantle swelled, lifted the crust, it stretched, contracted, cracked into a mosaic. Without plates, like on Earth, but hotspots were working. In 2022 models, the Rodinia breakup helped? Was there water? Granite says yes. Oceans helped. Why are they preserved? Altitude saved them from lava 500 million years ago. Hard, no erosion. In 2024, forest fossils were found. There was dry land. Tesserae are the key to the past. Venus with oceans? Veritas will analyze the composition in 2030. They are scars of youth when the planet breathed. Earth, our planet, but with many mysteries in its depths and past. Earth is our home, familiar from childhood, but full of secrets hidden in ocean abysses, ancient rocks, and even in the sky. We think we know it, but where did the moon come from? What lurks in the dark depths? How did life begin? Or why did the climate change so drastically? It's a world where the past whispers riddles and the depths hold the answers. Let's explore these mysteries step by step. Origin of the moon, impact, and alternatives. The moon is our constant companion, lighting the nights and affecting the tides, but where did it come from? Its size is huge compared to other moons, a quarter of Earth's diameter, and its composition is very similar to our planet, but with differences: little iron and water. This makes its origin a real puzzle that has puzzled scientists for centuries. The most convincing idea involves a giant collision in the distant past, but there are other options that try to explain how the moon appeared about 4.5 billion years ago, when the solar system was still a chaotic place. Imagine the young Earth had just formed, and a body the size of Mars astronomers call it Theia slammed into it. This impact was like a cosmic accident. Enormous energy ejected pieces of Earth's mantle and fragments of the impactor into space. The materials swirled into a disk around Earth, like Saturn's rings, and gradually clumped into a sphere, our moon. Computer models, updated in 2025 based on data from lunar missions, show that the impact must have been oblique at an angle to transmit the necessary momentum. This explains why the moon is composed mainly of light rock similar to the Earth's crust, but with almost no iron. The heavy core remained on Earth. Rock samples from the Apollo missions confirm the moon is poor in metal and volatile substances that could have evaporated from the heat of the impact. Plus, oxygen isotopes on the moon and Earth are almost identical. They are from the same batter. But there's a mystery. If Theia was foreign, why are there no traces of its unique composition? Scientists think the materials were completely mixed in the plasma from the impact, or Theia was born near Earth. Of course, not everyone agrees with this version. There is an alternative capture. The moon formed somewhere in the system as a separate world and was caught by Earth's gravity like a comet. This would explain its size, but not the similarity in composition. If it's from another place, the isotopes should differ. Plus, capturing a large body requires rare conditions, like passing by at the right moment. Another thought co-formation. Earth and moon grew up together from the same cloud of gas and dust, like twins. This gives a similar composition, but doesn't answer why the moon is so large and without an iron core. The gas disk should have distributed the metal evenly. Another option: fission. Early Earth spun so fast that a piece of the mantle tore off like dough from a mixer, but calculations show for this, an unrealistic rotational speed is needed, and Earth's present day would be shorter. In 2025, new models proposed a combination: a series of small impacts instead of one large one, which gradually accumulated material for the moon. This mystery is not just history, it explains why Earth is stable. The impact could have cleaned the orbit of debris. New Artemis missions, which in 2025 took samples from the moon's south pole, are looking for traces of water and metals to refine this. For now, the moon remains a reminder. Our satellite was born in fire, making Earth what it is. Deep ocean, trench and subglacial lakes, what is hidden oceans cover 70% of Earth, but their depths are like another world, full of mysteries. The Mariana Trench in the Pacific Ocean and subglacial lakes of Antarctica are places where pressure will crush, light won't reach, but life teems and geology surprises. These abysses hold secrets that we are only beginning to uncover, and they hint at what life in space looks like. The Mariana Trench is the world's bottom, with a depth of almost 11 kilometers. The pressure is like a ton on every centimeter. The temperature is about 2 degrees. The darkness is eternal. They thought it was empty there, but expeditions from the Trieste in 1960 to robots in 2025 found life: fish with flashlights, crustaceans, bacteria. These creatures eat sulfur and methane, not needing sunlight. In 2024, microbes were found chewing plastic. They adapted to the trash. But how do they survive? Their bodies are like rubber. Their membranes don't burst under pressure. The trench's geology is a zone where plates rub, causing earthquakes. Faults go into the mantle, possibly with ancient minerals or water from the depths. Seismologists in 2025 found channels leading hundreds of kilometers deep. What is there? Maybe traces of old oceans locked in stone. Antarctica's subglacial lakes are hidden beneath kilometers of ice, like Vostok, the size of Baikal. They've been isolated for millions of years. The water is -3 degrees, but liquid from pressure and Earth's heat. Samples in 2013 found bacteria that feed on minerals. In 2025, Russian scientists drilled deeper. DNA shows they are ancient like dinosaurs. How do they live without light? By chemistry, they oxidize iron like a battery. Lakes in the trenches, possibly with a network of tunnels, an underground ocean. Seismic data in 2025 showed they are connected, water flows slowly. These places are a mirror for Europa or Enceladus. If life is here, then it's there too. Missions in the 2030s with robots promise samples. The depths are a window into Earth's past where secrets wait in the dark. Origin of life, vents, comets. How did life emerge from stones and water 4 billion years ago? It's a puzzle, from simple molecules to cells. Two ideas lead: hydrothermal vents in the ocean and comets from space. They don't disagree, but complement. Let's examine. Hydrothermal vents are underwater geysers in faults where magma heats water to hundreds of degrees. Pressure is high, darkness, but chemistry is bubbling. Sulfur, methane, iron. In 1977, ecosystems were found there. Bacteria eat chemistry, not sun. Idea, amino acids, the basis of proteins, gathered here. Water dissolved minerals, creating a soup. Experiments in 2015 synthesized amino acids in these conditions, even RNA, the information molecule. Pores in the rocks are like cells where molecules accumulated. In 2025, lipids were found from membranes, stable, the ocean protected from meteorites. But heat destroys RNA, maybe in cooler zones nearby. Comets are icy visitors from the system's edge with water, amino acids, sugars. 4 billion years ago, bombardment. Comets carried organics. Rosetta in 2014 found glycine and phosphorus on a comet. Impacts created reactions like an oven. In 2025, peptides were synthesized from impact. Water isotopes in comets are similar to Earth's. Did they bring the oceans? Organics fell into puddles or oceans where they mixed. Maybe comets provided the ingredients and vents the kitchen. Other ideas: warm ponds with sun, like the Miller-Urey experiment, or ice in pores. The riddle: how did molecules start to copy? Missions to vents and meteorites are searching. Life from depths or stars. Lost continents: Zealandia, Mu. Continents drift, but some have sunk, like Zealandia or the mythical Mu. These lands remind us Earth changes, hiding the past underwater. Zealandia is the eighth continent, the size of India, around New Zealand. 94% is underwater, a kilometer deep. The crust is thick, with granite like Australia's. It was recognized in 2017. Drilling in 2018 found fossils of forests. Born 500 million years ago from Gondwana, it separated 100 million years ago. It stretched, thinned, and sank due to erosion. In 2025, ancient mountains were found taller than Everest. Why didn't it rise? The crust is thinner, sediments weighed it down. Mu is a 19th century myth, a Pacific continent, the homeland of a civilization, sunken 12,000 years ago. Churchward invented it from Polynesian legends, but science says no. Oceanic crust is thin. Basalt, not a continent. Research in 2020 found only volcanic plateaus like Ontong Java. Mu comes from myths about islands sunk by the sea after the ice. Not a continent, but poetry. Others: Kerguelen volcanic land, 100 million years ago, with soils. Mauritius A ridge from India. Plates submerge land. In 2025, drilling seeks life on Zealandia. The lost are a lesson. Earth hides history in the ocean. Climate secrets. Ice ages. Warming. Earth's climate is a history of sudden changes. At times, the planet was almost entirely covered in ice, and then suddenly became hot, like a greenhouse. Why did this happen? About 700 million years ago, Earth froze entirely. Even the equator was covered in ice and snow. This happened because carbon dioxide became too scarce. It was absorbed by rocks through weathering, and the sun was weaker then. But then volcanoes began to release gases, the ice melted, and the temperature sharply increased. 300 million years ago, when continents gathered at the South Pole, the cold struck again. Antarctica and Australia were covered in ice, and then it suddenly warmed. Where there should be ice, forests grew. Such jumps are likely related to changes in Earth's orbit. It either stretches or becomes rounder, and more or less sun hits. 55 million years ago, there was a sharp warming, by 8 degrees over thousands of years. Glaciers disappeared, tropical forests grew in the Arctic. The reason: release of methane and carbon dioxide, possibly due to volcanoes or thawing permafrost. Why is the climate so unstable? A small change and everything collapses: gases, orbit, position of continents. It's like dominoes. One falls and everything changes. Earth's past teaches. The climate can flip quickly, and this is important to remember today. Mars, the red planet, with hints of the past and life. Mars is a red ball in the sky that beckons us with rivers of the past, traces of life, and giant volcanoes. Once water flowed there, winds blew, and maybe someone lived. Now it's a cold desert, but every new image from rovers uncovers secrets. Let's find out what the red planet hides. Was there life? Methane? Lakes? Mars looks dead, but scientists see signs of life. Ancient lakes, methane in the air, and organics in the soil. The question is, did microbes thrive there billions of years ago? Or is it just chemistry? Let's look at the evidence that makes hearts beat faster. 4 billion years ago, Mars was warm and wet. Images from Curiosity and Perseverance show riverbeds, deltas, and lakes hundreds of meters deep. In Jezero Crater, where Perseverance has been roaming since 2021, there was a lake the size of Lake Superior. Clay and salt settled there like in Earth's places with life. In 2023, the rover collected samples. Inside were organic molecules, carbon chains, like DNA building blocks. Not proof of life, but a hint. Molecules were preserved from ancient lakes. And now, methane, a gas that bacteria make on Earth. It's been found on Mars since 2004. Curiosity sees spikes up to 100 parts per billion. Methane doesn't last long, it's destroyed by the sun, so a fresh source is needed. In 2025, the TGO orbiter sniffed out methane in volcanic zones. Maybe microbes in the soil cook it, like in Earth's swamps, or volcanoes. But organics near methane suggest possibly life. Perseverance in 2025 took samples from the Delta labs on Earth are looking for biomarkers, such as complex carbons. Other findings: black spheres in the rock magnetite, which bacteria build as a shell, and hydrogen sulfide in the rock's food for microbes. Mars lost its atmosphere, water is gone, but if life was there, it could be lurking underground. The Mars Sample Return mission in 2030 will bring back samples, then we will know. For now, Mars teases lakes, methane, organics. Was there a tiny world? Water disappearance. Where did it go? Underground flows. Mars is full of scars from water, canyons longer than the Grand Canyon, riverbeds, lakes. Once an ocean covered a third of the planet, enough water for a 40-meter deep layer, but now it's dry dust. Where did the water go, and is it hiding beneath the surface? Mars's atmosphere is thin, 1% of Earth's. Solar wind carried away gases over billions of years. Without a shield, water either evaporated or froze. Part flew into space. Spectrometers see vapor in the upper layers. Another part is ice, billions of tons under the polar caps, like in Antarctica. Phoenix in 2008 dug and found ice everywhere. But that's not all images show. There was water for an ocean. The main hiding place is underground. In 2021, Mars Express radars found a lake under the South Pole Cap 20 kilometers wide, 1.5 deep. The water is salty with minerals. In 2024, InSight heard underground flows are everywhere, like groundwater. Models say up to 30% of the water is in the crust pores, 1 kilometer deep. This is a huge reserve, enough for humans for millions of years. Why did it hide? Mars cooled, volcanoes silenced, the atmosphere left. Water flowed down, froze, or dissolved in the rocks. Seasonal flows, dark stripes in summer are from salt, melting the ice. Perseverance in 2025 found hydrated minerals water in crystals. The riddle: how much is liquid, and how much water is flowing like a river on Mars now? There could be whole lakes underground, but we don't know how many yet. If the lakes are alive, like on Earth, it's a chance for microbes. Future drills in the 2030s will check. Mars's water didn't leave, but hid, waiting for warmth. Olympus Mons. Is it active? Olympus Mons is the largest volcano in the solar system, 3 times higher than Everest with the area of Texas. Outside, it's a calm giant, but inside, is there magma? Did it erupt recently, and is it smoking now? Olympus was born 3 billion years ago. Lava flowed for millions of years, building a shield like Hawaii. Its height is 20 kilometers, its base 600 kilometers. Viking in 1970s saw fresh lava few craters, meaning it's younger than a billion years. In 2015, the Mars Reconnaissance Orbiter found cracks and depressions as magma stirring. InSight in 2018 listened, microquakes beneath the volcano like a heartbeat. Signs of activity, gases. TGO in 2025 caught sulfur and chlorine over Olympus from magma, thermal spots in the infrared, 10 degrees warmer in places, models. Mars's core is partially liquid, heat is rising. The last eruption 100 million years ago for a planet yesterday. Why isn't it smoking? Mars is small, cooled, but tides from Phobos heat it. Or it's asleep, waiting for a jolt. In 2025, young flows were found 50 million years old. The riddle: if it wakes up, lava will flood the plains, for colonists, energy, or danger. Olympus is a sleeping giant whose heart still beats. Spider forms, seasonal geysers. In spring on Mars, spiders emerge from the ground dark spots and grooves like legs. There are millions of them, up to kilometers long. Not alien seasonal geysers, but how do they work? In winter, carbon dioxide ice covers the poles. The temperature is minus 150. In spring, the sun heats, the ice subliments, gas and dust under pressure break through. High textico de nuke, fountains out, dragging dust, the spider is ready. High Rise in 2008 filmed, spiders are in the shade, then emerge. In 2025, video, gases erupt like champagne. Why seasonally? Summer on Mars is plus 20 in the day, ice melts. The dust is black, it heats faster, accelerating it. In 2024 models, under the ice A layer with salts and water like brine, gases lift it, drawing patterns. The spider lives for days, then is covered by dust. And do these geysers go deeper right to the underground lakes where there might be liquid water, maybe water from underground lakes? For life a key, liquid on the surface. Perseverance is looking for traces in the spider zones. These geysers are Mars's breath showing the planet is alive, breathing under the ice. Jupiter. Giant with storms and mysterious moons, Jupiter is the king of planets, 30 times heavier than Earth, with Earth-sized storms and moons where an ocean might splash. It's a gas ball that shaped the entire solar system, but its vortices and satellites are full of secrets. Let's dive into the chaos and depths of this giant. Great red spot? Why doesn't it vanish? The Great Red Spot is a vortex on Jupiter that has been visible through a telescope since 1660. A storm the size of Earth, red like a cyclops eye, has been spinning counterclockwise for 400 years. Ordinary storms die in days, but this one is eternal. Why doesn't it vanish, and what feeds it? The storm is an anticyclone where air rises in the center and falls at the edges. Wind speed is up to 600 kilometers per hour. Depth is hundreds of kilometers. Juno in 2016 dived closer. The spot is not flat, but a dome 50 kilometers higher with lightning inside. The color is from chemistry. Phosphorus and ammonia redden from the sun. But why does it live? Jupiter spins fast. A day is 10 hours, which twists the flows. Winds from neighboring zones feed the spot like a conveyor belt. Heat from below lifts the gas. Cooling from above presses it down. In 2025, Juno's model showed heat from the gas compression in the vortex holds the energy. The spot is shrinking minus 1,000 kilometers per century, but it's stable. Were there several spots? Old maps show in 1663, which merged into one. Maybe the spot is an old man and new ones will grow. The riddle, will it disappear? Juno says, enough energy for thousands of years. This is a window into the weather of giants. Hurricanes are weaker on Earth, but the principle is the same. The red spot is an eternal dance of winds on Jupiter. Europa, ocean under ice, life? Europa is a moon of Jupiter the size of our moon, but under a crust of ice is an ocean 100 kilometers deep, larger than all Earth's seas. The water is liquid from Jupiter's tides, and life might be there. How does the ocean survive, and are microbes stirring in the dark? Europa's ice is 10 to 15 kilometers thick. The cracks are red from salt. Hubble in 2014 saw plumes fountains of water into space. Galileo in the 90s heard magnetic signals from salt water under the ice. In 2025, Webb confirmed hydrogen and oxygen in the plumes are from water decomposition. Tides are key. Jupiter pulls Europa. The ice flexes, heats from friction, like hands in prayer. The heat melts the ice, the ocean splashes. The composition, water with salt, magnesium, like Earth's oceans. Hydrothermal vents at the bottom? Models say yes, volcanoes heat it, like on Earth. In 2024, silicon was found in the plumes from seabed rocks. Life? On Earth, microbes live in Antarctica, eating sulfur. Europa provides chemistry. Jupiter bombards the ice with radiation. Oxygen penetrates down. Carbon from comets. In 2025, simulations, enough energy for ecosystems. Plumes are like faucets. Water from the ocean spurts out, carrying molecules. Europa Clipper starts in 2028. It will fly by 50 times, measure the composition. The riddle, how much liquid? Are cracks a path for probes? If there is life, it would be the second in the system. Europa is an ocean in a shell where secrets splash under the ice. Hot Jupiters. Formation analogs. Hot Jupiters are gas giants hugging their stars, like Jupiter, but closer to the sun than Mercury. Temperatures are thousands of degrees. A year is days. Thousands have been found, but how did they get there? Jupiter is the model. It migrated inwards, then flew away. Ordinary Jupiters are born far away, where it's cold, but hot ones are near the star. Idea, the gravity of the gas disk pushes them inwards like a sleigh down a slope. In 2015, ALMA models showed the disk breaks the gas, the Jupiter slides closer. There are traces on Jupiter. It was 5 million kilometers from the sun, then resonance with Saturn threw it back. Migration over millions of years. Jupiter ate the inner planets, grew. Hot Jupiters are the same, but got stuck. In 2025, JWST saw atmosphere with silicon from the heat. The orbit is stable, tides heated, but don't tear it apart. Why don't all migrate? Jupiter in resonance was saved. Others without neighbors pressed close. The riddle, water in them. Jupiter is watery, our hot ones dry. JWST is looking for vapor. This is the story. Jupiter almost became hot, but left. Hot ones are brothers, lost in the heat of the stars. Saturn, with rings and strange forms. Saturn is the most beautiful giant, with rings like a saucer and moons full of water and lakes. But behind the shine are secrets. Where did the rings come from? Why is the storm hexagonal? And do the satellites breathe life? This is a planet where space plays with geometry and chemistry. Let's unravel its strangeness. Origin of rings, composition, duration. Saturn's rings are the brightest spectacle in the sky, thin as paper, but hundreds of thousands of kilometers wide. They are made of billions of icy pebbles, shining like snow. But where did they come from, and how long will they last? This is not just decoration, it's a story of destruction. The rings are 90% ice, 10% rock and dust. The pebbles range from a centimeter to meters, spinning at a speed of 50,000 kilometers per hour. Cassini in 2014 dived inside. The ice is pure, like in a refrigerator. Age. It seemed like billions of years, but in 2016, Cassini found the organics are fresh. Age is 100 million years young. Where from? The main idea is a moon broke up. An ancient moon like Mimas, caught by gravity, torn apart by the tide. The fragments are the rings. In 2025, models confirmed such a moon existed, its pieces are the rings. Another thought comet's impact scattered the ice, it got stuck. Or volcanoes of Enceladus, geysers feed the rings with snow. How long will they last? Icy rocks darken from meteorites merge. Models, in 100 million years dust, but Saturn is light, density less than water. The rings float. The riddle, why don't they fall? The gravity of a twin moon holds them. The rings are a moon's grave, beautiful and fragile. Hexagon. The hexagonal storm. At Saturn's North Pole is a storm, but it's not round. It's a hexagon. Sides are 30,000 kilometers. Wind is 500 kilometers per hour. How does the wind draw geometry? It's like a perfect hexagon in the sky. Voyager discovered it in 1981. The hexagon is sharp, like a ruler. Cassini in 2006 took a video. The wind on the edge is stable, the center is a vortex. In 2025, Hubble saw the hexagon changes color from yellow to blue. Why? Jupiter spins fast, the flows twist. Model. 3 vortices inside the hexagon stand like table legs, the wind flows over them. In 2018 experiment, water in a cup spins a hexagon. Heat from below lifts the gas, the pole cools it, stability. In the South Pole, a round vortex, no corners. Why the difference? The north is 10 degrees warmer. The riddle. Is it stable? Cassini heard sounds, the wind howling like an organ. The hexagon is a whim of speed where space draws figures. Enceladus. Geysers, ocean, life. Enceladus is a tiny moon of Saturn, only 500 kilometers across, but under its icy crust is a whole ocean. And from the South Pole, fountains of water erupt real geysers that eject tons of liquid into space. Where do they come from, and can life be there? It all started in 2005 when the Cassini probe flew by and saw jets hundreds of kilometers high erupting from cracks in the south. It's not ice, but vapor and droplets water from beneath the surface. Cassini even flew through the plume and caught samples. There was salt, silicon, hydrogen, and even complex molecules like in Earth's oceans. Why doesn't the water freeze? Saturn pulls Enceladus with tides, like the moon pulls Earth. This bends the ice, rubs it, heats it, and a liquid ocean remains under the 10-kilometer thick crust. It's salty, warm at the bottom, and it most likely has hydrothermal vents like black smokers on the Earth's seabed. And now the most interesting thing, hydrogen in the plumes is food for microbes. On Earth, such bacteria live in complete darkness, feeding on chemistry from rocks. If the same is on Enceladus, it means there could be a whole ecosystem. In 2025, models showed the ocean is warm, with minerals and energy, everything needed for life. The plumes are like an open faucet. Pieces of the ocean fly out of them. A future probe will be able to fly through and collect samples. Enceladus is not just an icy ball. It's a world where an ocean splashes under the crust and life erupts from the cracks. Maybe someone is already swimming there. Titan. Methane lakes, Earth analog. Titan is Saturn's largest moon, bigger than Mercury, and the only moon with a real atmosphere. Rain falls there, rivers flow, lakes stand, but not of water, but of liquid methane and ethane. It's like Earth, only in a cryogenic version, where oil plays the role of water. Titan's atmosphere is 1.5 times denser than Earth's, made of nitrogen and methane. The surface is minus 180 degrees cold as a freezer, but methane is liquid at that temperature, like gasoline. In 2005, the Huygens probe landed on Titan and sent photos: rocky shores, riverbeds, smooth lakes. The largest is the Kraken Mare, the size of the Caspian Sea. Methane rain falls rarely but powerfully. It washes out channels, creates deltas like the Nile. Lakes are in the north because it's colder there. Methane condenses. In 2015, Cassini saw waves on the lake, a methane tide, under the icy crust and ocean of water 100 kilometers deep. Heat from Saturn's tides and element decay keeps it liquid. In 2025, models showed between the water ocean and methane lakes a layer of ice, but tunnels might exist. And life. Methane is not water, but scientists think microbes are possible that breathe hydrogen and eat acetylene. Organics in the atmosphere, a thick haze of hydrocarbons like tar. The Dragonfly drone will arrive in 2037. It will fly over dunes, search for the chemistry of life. Titan is Earth in a mirror, the same rivers and seas but made of oil. It's a world where chemistry dances by its own rules, and maybe someone is already swimming in the methane rain. Uranus, lying on its side, giant with secrets. Uranus is an ice giant that lies on its side, like an overturned ball, with moons torn to shreds. Its tilt and strange satellites scream of a catastrophe in the past. This is a planet where space was turned upside down. Let's find out what happened to this unusual world. Axis tilt. Why Uranus lies on its side. Uranus is the only planet that spins like a rolling ball. Its axis is tilted at 98 degrees. The equator faces almost the sun, and the poles face sideways. On Earth, the 23-degree tilt gives us spring and autumn. On Uranus, 42 years of day on one pole, 42 years of night. It's as if someone tipped the planet over. It's not from birth. When Uranus was born, it stood straight, like everyone else, but billions of years ago, a body the size of Earth crashed into it. The impact was sideways, like a shove to the shoulder. The planet flipped over, the axis lay horizontally. Computer models show the impactor hit at an angle, sheared off part of the mantle, but didn't break the core. The energy went into the tilt. Because of this, the seasons are madness. One pole is in darkness for 21 years, the other in light. The rings and moons circle lying down, like a plate on its side. In 2025, scientists refined. The impact was single, powerful, and the body was icy, like Uranus itself. And if not an impact, maybe tides from neighbors. But Jupiter is far away, or a series of small jolts. Models say a single big one is needed. Uranus is like after an accident, lying down, but alive. Miranda is Uranus's smallest moon, only 470 kilometers in diameter, but its surface is like a patchwork quilt. Giant canyons 20 kilometers deep, cliffs higher than Everest, chaotic patches. It looks like the moon was assembled from fragments and glued together. What tore it apart? Voyager flew past in 1986. Images showed cracks like a spiderweb, and Verona Rupes, a canyon 3 times deeper than the Grand Canyon. The surface is young, few craters, meaning it was recently restructured. An idea. A massive impact shattered Miranda into pieces, and gravity reassembled it. In 2020, models showed a collision with a body about 100 kilometers across demolished the moon. The fragments fell back, creating the chaos. Another version, tidal heating. Uranus pulls Miranda, the ice melted, swelled, and cracked, like dough in a mixer. In 2025, calculations, a combo, impact plus tides. The patches are different epochs, old smooth plains, new faults. Why didn't it destroy itself? Small but tough. Uranus's ice is like concrete. Miranda is like a puzzle after a storm. The mystery, is there an ocean under the ice? Future missions in the 2030s will check. It's a scar of a catastrophe where the moon survived an apocalypse. The collision that flipped Uranus. The collision that flipped Uranus lies on its side. Its moons are torn apart. Everything screams of a big impact. What was this body, and how did it change the planet forever? Let's reconstruct the cosmic accident 4 billion years ago. The main suspect is a protoplanet the size of Earth, born in the disk around the sun. The impact wasn't direct, but oblique. The body flew in at 10 kilometers per second at an angle, shearing off the outer layers. The energy melted the mantle, and the axis flipped over. 2015 models show the impactor lost its core, which merged with Uranus, adding metal. The shell scattered, becoming the rings and moons like Miranda. Why this way? Uranus is an ice giant, light, so the impact easily knocked it over. In 2025, simulations considered the body was icy, like Uranus, a perfect match. Consequences: Heat went inward. The surface cooled to minus 200 degrees. The magnetic field is skewed from the impact. The moon's fragments gathered into chaotic orbits. Alternatives? Many small impacts, but they wouldn't flip it entirely. Rejected in 2024, a single powerful one is needed. The mystery, where did the body go? Its ice is in Uranus's atmosphere. The future Uranus orbiter mission in 2038 will check the composition. The collision was the rebirth of Uranus. Planet, moons, rings, all from one accident. This is a story of survival in the chaos of the solar system. Neptune is the solar system's last giant, blue and distant, with winds faster than jets, and a moon that goes against the flow. Cold, 30 Earth distances from the sun, yet it's bubbling with life. This is a planet where the wind roars, storms dance, and the satellite is an outsider. Let's uncover its wild secrets. Dark spots, storms, disappearance. On Neptune, storms are not just clouds, but dark spots that appear and vanish like a magic trick. The most famous is the Great Dark Spot, Earth-sized, black as a hole. It swirls, devours light, but suddenly disappears. Why are these vortices so capricious? Voyager in 1989 saw 3 spots, dark ovals in the blue atmosphere. The Great One, southern, 8,000 kilometers long, 400 km/h winds. Hubble in 1995 photographed it, black due to the absence of methane, which absorbs light. In 1995, the spot vanished, dissolved over years. In 2018, Hubble found a new one, smaller but alive. Why do they disappear? Neptune's atmosphere is hydrogen, helium, methane. The spot is an anticyclone. Air descends, cools, methane freezes, the area darkens. But wind currents tear it like paper. 2025 models show heat from below feeds it, but collisions with other vortices destroy it. A new spot in 2024, smaller but growing. The mystery, why are they unstable? Neptune heats internally 3 times more than it gets from the sun. Heat churns, storms are born and die. On Jupiter, the spot is eternal. On Neptune, it's a show. In 2025, JWST saw the spots change shape annually. These dancing holes are the heart of Neptune's storms, where the cosmos plays hide and seek. Winds, 2,000 km/h, energy. Winds on Neptune are the fastest in the system, up to 2,000 kilometers per hour, faster than sound. A plane flies 800, and the hurricane here is 3 times stronger. Where does such fury come from on a cold planet where the sun is a dim lamp? The atmosphere blows in bands, blue and white zones, speed changes from minus to plus 2,000. Voyager measured retrograde and prograde winds, like a carousel. In 2019, Hubble saw winds accelerated by 20% over 30 years. The energy is not from the sun, it provides little heat. Neptune heats internally, gravity compresses the gas, heat escapes. In 2025, JWST models confirmed internal heat is 4 times stronger than solar. This lifts the gas, swirls the vortices, convection, like boiling water in a pot. Plus rotation, a 16-hour day, the currents fly. Methane adds to it. It absorbs red light, making it blue, but freezes in storms, amplifying speed. The mystery, why is it faster than Uranus? Neptune is hotter inside, a mystery of heat. Winds change, slowed by 10% in 2024. This is the planet's pulse. Heat pushes the air like a pump. Neptune is a wind machine where fire boils inside. Triton, retrograde orbit Triton, is Neptune's moon, larger than the moon, but circles against all others, retrograde, like a rebel. Its orbit is close, taking 7 days, and it's falling inward. Where did this outsider come from, and why does it go backward? Voyager in 1989 flew by. Triton is ice, nitrogen, geysers shoot 2 kilometers high. The surface is smooth, few craters, young. Orbit, 160-degree tilt against Neptune's rotation. Moons are usually with the planet, Triton is not. The idea, capture. Triton was born in the Kuiper Belt, billions of kilometers farther. Neptune caught it with gravity, like a fly in a web. In 2015, models showed capture was slowed by gas, the orbit stabilized. The retrograde orbit is the mark of an outsider. Why is it falling? Tides. Triton pulls Neptune, loses energy, spiraling inward. In a billion years, it will be torn apart, new rings. In 2025, calculations, collision in 3 billion years. Geysers, nitrogen melts from tides, shoots into space, ocean under the ice. In 2024, spectra, water and organics, the mystery, life. Triton is a mini Kuiper object, a caught fugitive whose orbit is a countdown. Pluto, dwarf with unexpected features. Pluto is a small sphere at the edge of the system, demoted to a dwarf, but full of surprises. A heart of ice, an atmosphere that melts and freezes, and a double life with a moon. New Horizons in 2015 showed it's not an icy lump, but a world with mountains and rivers. Let's explore why Pluto is the king of the dwarfs. Dwarf status debates Pluto was the 9th planet until 2006, but now a dwarf. Why was it demoted? And do scientists still debate? This is a story where size isn't everything and the rules are strict. In 2006, the International Astronomical Union decided a planet must clear its orbit of debris. Pluto is in the Kuiper Belt, a crowd of icy spheres, and couldn't. Its orbit crosses Neptune's, neighbors are abundant. Criteria: round, holds its orbit by gravity, dominates its surroundings. Pluto is round but doesn't dominate, dwarf status. Disputes rage. Mike Brown, who discovered Eris, says dwarfs are normal planets. In 2025, a petition, restore the status, add a class. Astronomers argue 1,000 dwarfs in the Kuiper Belt. Are they all planets or a separate category? Pluto is unique. Atmosphere, geology, like big ones. Eris, make, similar. In 2024, a vote, 70% for dwarf planets. The mystery: if added, the system would grow. Pluto teaches boundaries are conditional, even at the edge. Tombaugh Regio, smooth surface. Tombaugh Regio is a vast plain on Pluto the size of Russia, pinkish beige without craters. It's like fresh snow, younger than Europa. Why so smooth, and what's underneath? New Horizons in 2015 captured it. Tombaugh is 500 kilometers wide in the center of the heart. Smooth as a table, no craters, age less than 1 million years. Around it, mountains of water ice 5 kilometers high. The plain is nitrogen ice like plasticine. Why smooth? Cracks and flows. Nitrogen melts, flows, smooths. In 2018, models, convection. Ice is warmer below, rises, cold sinks, like boiling water. Stirs the surface, erases craters. Heat from Charon's tides, the double system flexes Pluto. Color from methane and sulfur, like a sunset. In 2025, JWST spectra. Ocean under the ice, mountains float on it. The mystery: volcanoes? No craters, recently refreshed. Tombaugh is a living heart where ice breathes and flows. Atmosphere, evaporation, freezing. Pluto's atmosphere is thin, like smoke, made of nitrogen, methane, carbon monoxide. When the orbit approaches the sun, it grows, evaporates. When it retreats, freezes, like breath steam in the cold. Thickness, 100 kilometers, pressure 100 millionth of Earth's. New Horizons saw a blue haze, pressure dropping. The orbit is an ellipse. Closer, plus minus 150 degrees, ice melts, gas to the sky. Farther, minus 230, nitrogen falls as snow. The cycle is 248 years. Now it's winter, the atmosphere shrinks by 20%. In 2018, models loses 1 billion tons beyond the orbit. Gas condenses on Tombaugh, the plain grows. Methane shines like a rainbow. In 2025, JWST, ions in the atmosphere from the sun. The mystery: does an ocean under the ice evaporate? Or is all the water frozen? The cycle is Pluto's breath, melts, exhales, freezes, inhales. The atmosphere is a living blanket changing with the seasons. General mysteries and exoplanets, beyond, the search for life beyond. Neptune and Pluto, the solar system doesn't end. There's the Kuiper Belt, and further, thousands of exoplanets circling alien stars. We are searching for Planet 9, biosignatures of life, and awaiting missions that will change everything. This is the boundary of the known, where the cosmos whispers about neighbors. Let's peer over the edge. Planet 9, hypothetical. In the Kuiper Belt, beyond Pluto, strange orbits, icy spheres circle not as they should. Scientists say Planet 9 is hiding there, a giant 10 times heavier than Earth, at the edge of the system. Why can't it be seen, and does it really exist? In 2016, Mike Brown and Konstantin Batygin noticed the orbits of Sedna and others are elongated, clustered, as if an invisible hand is pushing. Models: a planet with the mass of 10 Earths, 30 times farther than Neptune, orbit, 10,000 years. Its gravity shepherds the Kuiper Belt. Where from? Born in the gas disk, migrated outward, or captured Neptune? In 2025, the Vera Rubin telescope is searching, empty so far, but there are traces. JWST in 2024 saw orbits are being adjusted. Debates: not Planet 9, but the Kuiper disk pushes itself? But Brown's models are more accurate. If we find it, the system will grow. The mystery: icy giant or rock? Planet 9 is a shadow at the edge, awaiting light. Biosignatures: what to look for in atmospheres? We have found thousands of planets around other stars, from rocky spheres to gas giants. But how to tell if there's life? Scientists look for biosignatures, gases in the atmosphere that cannot appear on their own, only thanks to living organisms. The main sign is oxygen. On Earth, plants and algae make it. If a distant planet's atmosphere has a lot of oxygen and methane, that's strange. These gases react and vanish quickly. So someone is constantly replenishing them. Life. Methane is also important. On Earth, cows, termites, and swamp bacteria release it. If methane appears in bursts on an exoplanet, that could be biology. In 2024, the James Webb Telescope found methane on planet K218b and water there too. Not proof yet, but a hint. Phosphine is another marker. On Earth, only microbes in oxygen-free conditions make it. When it was found in Venus's clouds, everyone gasped, although it later turned out perhaps volcanoes. But on cold exoplanets, phosphine doesn't survive without life. There are rare ones. Dimethyl sulfide smells like the sea, algae make it on Earth, or ozone, a shield from UV, only appears with oxygen. Telescopes like JWST look at the star's light through the planet's atmosphere. If there is oxygen plus methane plus water, it's like a green light. Life is possible. So far, it's all just hints. But every year we are one step closer to the answer. Are we alone in the universe? Future missions, what they will reveal. We aren't just looking through telescopes, we're flying. New probes and telescopes will soon reveal whether there are oceans under the ice, life in methane lakes, and oxygen around alien stars. Here's what awaits us in the coming years. Europa Clipper launches in 2028. It will make 50 flybys over Europa, Jupiter's moon. It will fly through water plumes, collect samples, check, is the ocean salty? Are there organics? If it finds them, life may be under the ice. Dragonfly will arrive at Titan in 2037. It's a drone that will fly over methane lakes, land on dunes, and search for complex molecules. It will show, can life breathe methane? Da Vinci and Veritas to Venus in 2030. One probe will descend into the clouds, take samples, check for phosphine. The second, a radar, will map the surface. Were there oceans? Are volcanoes active? Uranus Orbiter in 2038 to Uranus. It will study the tilt, rings, moons, understand what flipped the planet. Neptune Odyssey to Neptune will analyze winds, Triton, geysers. JWST and Nancy Grace Roman are already flying, but in the 2030s we'll find thousands of exoplanets. Habitable Worlds Observatory in 2040, the first telescope to photograph the atmospheres of planets in the habitable zone. It will see oxygen, methane, water. Sample return from Mars in 2037 will bring back rocks with organics. Laboratories on Earth will say, was there life? These missions are not just metal. They are our eyes, hands, and ears in space. Soon we will know, are we alone? We have flown through the entire solar system, from the icy traps of Mercury to the methane rains of Titan, from the heart of Pluto to the biosignatures around alien stars. Planets are not dead rocks, but worlds with history, storms, oceans, and possibly life. Every mystery is a door that we have only slightly opened. And now it's your turn. Write in the comments, which mystery captivated you the most? Where do you think we will find life first? On Mars, Europa, or in the clouds of Venus? Which planet would you visit if you could? Subscribe, turn on the bell. More bedtime stories are coming. Good night and sweet cosmic dreams.